Alright, so the biggest difference that we're going to see between covalent and ionic is that in our covalent compounds, they're going to share electrons, okay? Which is different because in ionic, we see that one element is giving electrons and one is going to receive it, okay? And we already showed these with your Lewis structures, alright? But just to highlight, what we're saying is this. If we have something like hydrogen, which has one valence electron, okay? And we have something like fluorine, which has 1, 2, 3, 4, 5, 6, and 7. What ends up happening is these guys are going to share this one electron here, so that you end up with it looking kind of like this. So I'm going to draw these like that. I'm going to draw it with an X so you can see that that's the one electron that has been shared. So your electrons that are being shared in this case, okay, are these two right there in the middle, right? So this is different than if you had an example like, I don't know, let's go with sodium. So if I have Na, which is a 1, right, has one valence electron, and fluorine, which has 1, 2, 3, 4, 5, 6, and 7. Remember, this one electron is leaving so that my Na has a 1 plus charge, and my fluorine now has all 8 of its valence electrons and has a 1 minus charge. So the difference is this. This is going to be with a metal plus a non-metal, right? But with our covalent compounds, okay, these are always going to be a non-metal plus a non-metal, right? So let's go and see a couple other examples. Alright, so let's say we have something like, let's say we actually have fluorine, which is 1, 2, 3, 4, 5, 6, 7, okay, plus another fluorine, which has 1, 2, 3, 4, 5, 6, and 7. So when these two come together, they're going to share that electron, those two electrons there. So what you end up with is 1, 2, 3, 4, 5, 6, 7, and then we take our other fluorine, put it here, 1, 2, 3, 4, 5, 6, 7, so that the electrons that they're sharing are right there in the middle. And so a lot of times the way that we're going to write this is we're actually going to write this as a bond, so that anytime you see this right there, this equals 2 electrons. Okay? Alright, so let's go with maybe a little bit more, well, you guys have seen this one before, so let's look at water, okay? So we know that the formula for water is H2O. So if we draw our O, we know that it has 1, 2, 3, 4, 5, 6 electrons, okay? And we know that we've got a hydrogen that has 1 electron. So what you can imagine is, instead, we're going to move this hydrogen closer, okay? And we're going to share that 1 electron there. And so again, this 2 means that we have 2 hydrogens. So now I can put my second hydrogen there, and you can see that that would be our example, okay? Now, since we know that, we're going to draw this, and we're going to say that this is H. We're going to put our O's, okay, so that we have our bond there. Now, let's also talk about how we would name these, okay? Now, when we do this, we still keep the same thing, the endings are the same. So one, my endings are going to be IDE, okay? So in this case, we have oxygen, and so we know that that's going to be an ending of oxide, right? Okay, so that part is easy. So then we have to look at our first element, okay? And so again, we just name, sorry, that's an M, I need an N. We just write the name, of the first one. So I'm going to write the name of the first element, and so this is just going to be hydrogen. Okay, so that's hydrogen. Now, here's where it gets interesting. Right here we have a 2, okay, which means that we have 2 H's. So we're going to call this dihydrogen because there's 2 of those. How many oxygens are there? There's 1, so 1 is mono, and so this is going to be dihydrogen monoxide. So let me write it again here. Dihydrogen monoxide. All right, so here we go. We said the first thing that we wanted to do was, I'm going to write these rules in a little different order, but first thing is write the first element. Okay, so we write the first element. Then you're going to add if there is a prefix. So add the prefix. So in this case, mono is 1, di 2, tri 3. What's 4? 4 is tetra. Penta is 5. Hexa, that's an H. Yeah, let me just erase it so you guys can see it better. Okay. Hexa. Hepta. Octa is 8. Nona is 9. And deca is 10. All right, so that's 10. So in this case, we'd say we're going to add the prefix. So if we've got something like we said with our H2O, we said that this was dihydrogen. Okay. Part 2. So for part 2, you want to write the prefix. Oops, sorry, the wrong tool there. You're going to write the prefix. Then you're going to write the element. And then change ending to IDE. So in this case, we said that this was then going to be 1 oxygen, so it's monoxide. Okay. Now, only, that's a Y, use mono for the second element. Okay, and I'll show you on the next slide what I mean by that. So if I have an example like CO, okay, so this is going to be, you would want to write, since there's only 1 carbon and 1 oxygen, you would want to write monocarbon monoxide. But we know that since we don't write it for the first element, it's just going to be carbon monoxide, which you guys are very familiar with, okay? If we look at something like this, CO2, again, we would say carbon dioxide. Change my ending of oxygen to IDE. We wouldn't say monocarbon dioxide. Let's go with another example. C2H4. This would be dicarbon. Okay, and then tetrahydride. Okay, something like P4O10. This would be tetraphosphorus. Deca, or you can say deca oxide, or you can say dec oxide. Either way, okay? All right, so now we're going to go the opposite way. So what if I'm given a name like this? Carbon And let's go with carbon disulfide. Well, I know my ending IDE, and so that's going to tell me that it's from the periodic table, so it's not a polyatomic ion. So sulfide is coming from sulfur, and di means 2, so I'm going to have 2 of these. And carbon, since there's nothing in front of it, I know that there's just 1. So this is going to be CS2. Okay, so what if I have something like dicarbon, let's go with hexahydride. Well, hydride comes from hydrogen, okay? So hex meaning 6, so there's going to be 6 hydrogens, and dicarbon meaning C2. Okay?